Okay, this is the section 8.1 notes, graph of the sine and cosine functions. So you'll notice that when we talked about the unit circle, we created these ordered pairs with cosine and sine based on a given angle. So we've defined a point with two parts that change based on the size of the angle. So we want to be able to relate the angle in one of those parts, the cosine or the sine, so that we can graph them and see what kind of patterns we can see, what's useful, all the good stuff we get from graphs. So we're going to start here. I'm going to start with the cosine function, just because that's first. I'm going to list theta and then cosine of theta. So you'll notice our two graphs below have the x-axis, that horizontal axis, labeled as theta. That's our input. Our output is f of x, so it's either cosine of theta or sine of theta. Okay. And because I'm super lazy, I'm not going to try to graph square root of 3 over 2, square root of 2 over 2. 1/2 is okay. I'm going to go with the pretty straightforward and easy parts. Okay, so the cosine at 0 is 1. Straight up and down, that cosine of pi over 2 is 0. Continuing around the circle at pi, I get a cosine of -1. At 3 pi over 2, I get 0. And then back at 2 pi, I get 1. And so if we look, this graph in the green, I've got the point 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi, 1. So this green graph over here is our graph of cosine of theta. I've listed this twice, f of theta or y equals cosine theta. We can assume kind of maybe the other graph is sine, but we're going to give it a shot here and take a look. So we've got theta and then sine of theta. I'm going to choose the same points, the same angle measures, because these ones are the super easy ones to graph. Pick a different color here for sine. Here are those sine values. So at 0, the sine is 0. At pi over 2, the sine is 1. At pi, the sine is 0. At 3 pi over 2, the sine is -1. And at 2 pi, the sine is back to 0. Here's my 0, 0. I got pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. So this graph on the left-hand side is the graph of sine theta. Okay. There are a lot of different ways to look at this, and there are a lot of different ways online. I have linked one animation of the sine and cosine. Kind of neat. It maps around the unit circle as the curve is drawn. Please make sure you go down on the left-hand side and make sure that button next to sine animation or cosine animation is turned on. A little entertaining to watch them both go at the same time. Also a little confusing. Okay. So we have a special name for these types of graphs. These are called sinusoidal graphs. Sine and cosine are sinusoidal, which means the sine and cosine functions are called sinusoidal functions. And any function that behaves this way, that repeats or is cyclical, is called periodic. So you'll notice the bottom here of page 1, I've got this little graph from before, but then it's been expanded out beyond one period or one cycle. So these continue because we can rotate around that unit circle as many times as we want. We can plug in those angle measures. Those can go on forever. But as long as you know what it looks like in one period, you can graph the whole thing. Okay, so on to page 2, a couple things we want to remember. These are periodic functions with a period of 2 pi. That means until we start messing with it and changing things up, this will always repeat every 2 pi, which makes sense. Once around the circle is 2 pi. The domain is always negative infinity to infinity, and the range, we talked about this in the last section, is confined to negative 1 to 1. Our unit circle does not go past, we've got a radius of 1, so it does not go past 1 in any direction. Okay, we can take a look at that sine graph. It's symmetric about the origin, which means if you take that page 1 and rotate it 180 degrees so it's upside down, the function will look exactly the same. That makes sine an odd function, and we talked about that in the last section too. Our cosine function, we can fold along that y-axis, the line x equals 0. It looks exactly the same on both sides. Our cosine is an even function. Okay. Halfway down page 2, graphing variation. So the general form of these functions look either like this, y equals some multiplier a times the sine of the quantity bx minus c plus d, or we can substitute cosine in for sine. Okay. A, and you notice here we've got an absolute value. That's the amplitude. That tells us how far up and down our graph is going to go from the midline. So this is how far above and below the midline. And so now you're going, wait a minute, what's a midline? And it is, go with your gut, it's what you think it is. Let's go back up to one of these graphs. The midline is the line that just runs through the middle of the graph. Looks exactly the same above and below, maybe offset a little. For any parent function, the midline's going to be the x-axis. As we move things around, that midline's going to change. It's going to move. 2 pi over b is the period. So that is the length of one cycle. C over b is called the phase shift. That's our horizontal shift. Tells us how far we move our graph, left or right. And then D is the vertical shift. You may remember that from other parent functions. That's how far we move our graph up or down. Okay, so let us see if we can crank through some of these. We will talk about how to use these in subsequent pages. Right now we're just going to kind of crank through and make sure we're okay finding these values. I'm going to move that line over a little. And since I am abbreviating here, our phase shift, PS, and our vertical shift, VS. Okay, so our amplitude, and I will write this out the first time. Absolute value of A, we've got the absolute value of negative 0.5. Our amplitude here is 0.5. That first function is going to go 0.5 above and below our midline. Our period, 2 pi over B. 2 pi, the B here is 2. So we have a period of pi. This graph is going to repeat every pi units. Our phase shift, C over B. We've got pi over 2 over 2, which gives us pi over 4. So this graph is going to move pi over 4 to the right. And our vertical shift, what we're adding or subtracting at the end, is 1. This whole graph is going to move up 1. And I'm going to go ahead and change colors just so it's a little easier to distinguish here. So B, this might be a good time if you want to give a shot at B and C on your own first and then come back and compare, to pause the recording. Okay, and we're back. And B, absolute value of -2. The amplitude for the function is 2. 2 above, 2 below. Right? The period, 2 pi over B. Here B is 4. That reduces to pi over 2. Our phase shift, there's one thing that I want to point out. Keep in mind up here, we've got bx minus c. This is written as a plus. So to make sure we have the correct c, keep in mind it would really look like that, 4x minus -2 pi over 3. So I've got a -2 pi over 3 over b, which is 4, which gives me a -2 pi over 12, -pi over 6. Vertical shift, we don't have anything being added or subtracted at the end, so there is no vertical shift on this one. C, our amplitude is 3. Our period is 2 pi over 6, which looks a little different than we're used to. Keep in mind, whenever we divide by a fraction, it's the same as multiplying by a reciprocal. So that gives me 2 pi times 6 over pi. My pi's cancel. I get a period here of 12. Looks a little different than the first two. There is no pi involved. Keep in mind, in real life situations where our period is based on an amount of time, it may not be divided up into pi units. Our phase shift, we have got, again, same thing here. I got pi over 6x minus pi. So I have got -pi over pi over 6, -pi times 6 over pi. I get a phase shift here of -6. Makes sense, kind of in line with the period being 12. Our vertical shift, after the fact here, we are subtracting 4. So our vertical shift is -4. This whole graph is going to move down 4. And that's the end of page 2.